Here we have to prove that the solution of this integral equation is ux is equal to e power x 1 plus x square by using resolvent kernel. So the given equation is ux equals to 1 plus of x square plus 0 to x 1 plus x square upon 1 plus t square ut dt. This we can see that this equation is in a form of Volterra integral equation of second kind. So we comparing it with Volterra's integral equation of second kind. What is Volterra integral equation of second kind? That is yx is equal to fx plus of lambda integral 0 to x k xt yt dt. Let this is equation number 1. Now compare the equation number 1 with equation number 2. You will get fx is equal to, here fx 1 plus x square, lambda equals to, so here lambda's value is 1, so 1, kxt is this one, kxt and yt dt, 1 plus of x square upon 1 plus t square, which is also the value of k1 xt. So in way to find the resolvent kernel, you have to find k1 xt, k2 xt, k3 xt. So we know that km xt is integral t to x kxz into km minus 1 zt dz. With this equation we can find k1, k2, k3 xt. So this is k1 xt, we have to find k2 xt. Now the k2 xt is t to x kxz. So this is kxt, we can put z t equals to z in this equation, we get kxz. So kxz is 1 plus of x square upon 1 plus of z square here. Now km minus 1 zt for k2 xt is k1 xt, k1 zt. So z, so we put x is equal to z in equation number this, we get km minus 1 zt. So that was 1 plus x की जगह पे z square and now 1 plus t square, now we get dz. So you will get 1 plus x square upon 1 plus t square na, t2x 1 plus x square upon 1 plus t square dz. So this is independent of z na, we'll take it outside the integral. It is independent of z, so it is constant for this integral. So we take this outside the integral, we get 1 plus x square upon 1 plus t square integral t to x 1 dz. Now 1 dz is z. By putting this value we get x minus t. So it will become 1 plus x square upon 1 plus t square x minus t. This is k2 xt. Now we have to find k3 xt. So k3 xt can be written as t2x 1 plus of x square upon 1 plus of z square, which is k z xz. Now km minus 1 zt, for this is k2 zt. Putting x is equal to z, we get 1 plus z square upon 1 plus t square z minus t dz. Here 1 plus z square, 1 plus x square, 1 plus t square are independent of z. So we take it outside, and for z minus t we'll get z square upon t square, which will become, after putting this integral, so we get it as what? k3xt is 1 plus of x square upon 1 plus of t square z square upon 2 fact 0 to x. So sorry, t to x. So this is 1 plus x square upon 1 plus t square, x square minus x minus t's square upon factorial 2. We can write it as factorial 2. This is, we can also write it as factorial 1. So we get km, so on km xt as what? 1 plus x square upon 1 plus of t square, this is x minus t, m minus 1 upon m minus 1 factorial. Now you have to find out the resolvent kernel. So you can write resolvent kernel, which is kxt lambda. It is equals to summation of m equals to 1 to infinite 1 plus x square upon 1 plus t square x minus t m minus 1 upon m minus 1 factorial. What you know, e power x is equal to x plus x square upon factorial 2 is factorial 1 plus, and so on. When you get these values, m is equal to 1, 2, 3, 4, you'll get the same equation. So this is e power x minus t's expansion. You can write it as 1 plus x square upon 1 plus t square e power x minus t, which is your resolvent kernel. Now equation number 3 say, you know the solution will be given by yx is equal to fx plus of lambda integral 0 to x r x t lambda resolvent kernel into ft dt. Put all those values we have. Fx is equal to 1 plus x square, lambda's value is 1, 0 to x, this is x, 1 plus x square upon 1 plus t square, e power x minus t, ft is 1 plus t square, and this is dt. Now 1 plus t square, 1 plus t square. What you'll get? 1 plus x square plus of 1 plus x square 0 to x e power x minus t dt. Now you know na, e power x minus t can also be written as e power x into e power minus t. So we'll take e power x outside the integral as well, and taking 1 plus x square in common. So 1 plus x square 1 plus of e power x 0 to x e power minus t dt. What is the integral of e power minus x? E power minus x is minus e power minus x. This will become 1 plus of x square 1 plus e power x minus e power minus x minus e power minus x 0 to x. So you can write it as 1 plus x square 1 minus of e power x. This will become, when you put here x, this is e power t, so sorry, x, to e power x into e power x 1 plus e power x minus e power minus x 0 to x. So you can write it as 1 plus x square 1 minus of e power x 1 minus e power minus x minus e power t. So this will become, when you put here x, this is e power t, so sorry, x to e power x into e power x 1 minus e power x minus e power minus x 0 to x. What is the integral of e power x? minus of, on putting 0 you will get e power 0, so e power 0 is equal to 1, so this will become 1. 1 plus of x square, 1 minus e power x, e power minus x, e power 0, minus minus plus of 1 into e power x. Since e power 0 is equal to 1, we will get 1 plus x square, 1 minus 1 plus e power x, which will become 1 plus of x square e power x. Therefore, ux is equal to 1 plus of x square e power x, which is the required equation, required solution. So, hence proved. If you like it, please like, share and subscribe.